So if we start by factoring this one, negative 2x squared, on the bottom is a difference of squares, x plus 5 and x minus 5. We have non-permissible values. X can't equal negative 5 and x can't equal 5. Are they going to be wholes or are they going to be asymptotes? In this case, since none of them cancel out, they're going to be both asymptotes. So when we say non-permissible values, it's okay to write x can equal 5, x can equal negative 5. When we write equations of asymptotes, the equations are always with an equal sign. So when you're labeling your equations of your asymptotes, that's an equation, it has an equal sign. Even though it's a non-permissible value, says those are what x can't equal. As far as your equations of your asymptotes go, when you're labeling them on a graph, that's with an equal sign. So that's step one. Now, because this one didn't simplify to a line like the last one, we're going to have to check if it has horizontal asymptote or an oblique asymptote. In order to check that, what you're going to do is you're going to look at the highest power or the highest degree in this whole equation. So of all of our x's, x squareds and stuff, can you see that x squared is the highest degree that you have in this rational function? And if we look at that, and I'll just title this horizontal / oblique, this is what we're checking for. If we look at the highest power, on the top we have a negative 2x squared, that's the highest degree that we have. On the bottom we have one of those, and we ignore everything else other than that highest degree. If this is possible, if you can simplify this and get an answer, that'll be a horizontal asymptote. If this is impossible, and we'll see some later where it's something divided by 0, because you won't have x squareds on the bottom, then you're going to get an oblique asymptote. So in this case, does this simplify? Yes, it simplifies to negative 2. So that means y equals negative 2 is a horizontal asymptote. Is that all right if I abbreviate that as HA? Ha. Okay. So now we have a horizontal asymptote. We won't have a vertical asymptote. We won't have an oblique asymptote in this example. So we found all of our asymptotes. We can also find our X-intercepts and Y-intercepts. Our X-intercept, would our fraction ever equal 0? In order for a fraction to equal 0, the numerator has to equal 0. When does that happen? When x is 0. What about Y-intercepts? Y-intercept happens when x is equal to 0. That's often easiest to figure out with your original equation. Plug in 0 for x. What do you get? 0. So in this case, our X-intercept and our Y-intercept are the point 0, 0 for both of them. Now when we go to sketch the graph, what we're going to do is we're going to label all of our asymptotes. So we have an asymptote here at x equals 5, another one here at x equals negative 5. And we have an asymptote at y equals negative 2. And we found out that the only x-intercept is at 0. Okay? Now generally what we do is we find one point in each section, and by each section That's going to be separated by our vertical asymptotes. So this one's going to have three sections, something less than -5, something between -5 and 5, and something bigger than 5. So when I check, I've already got something in between -5 and 5. If I put in a point less than -5, say I choose x equals -6, and I plug that into my equation, what do I get as a point? Well, if I use the factored one here, can you see that I'm going to get -72 on top? Because -6 squared is 36 times the -2 will be -72. And on the bottom, this will be -1. And here I'll have -11. Which will give me -72 over 11. Not a really nice number, but as far as an estimate goes, we can say that that's going to be down there. Because -72 over 11 is going to be close to between -6 and -7. So I know that it's in this section. What that's going to tell me is that this graph, when it goes towards the asymptotes, is going to act like that. Same thing when you plug in something in the third section when x is equal to 6. I'll go back up to my equation now. When x is 6, I'll still have -72 on the top. And on the bottom, when I plug in 6, can you see that I would get 11 and 1? And that still works out to -72 over 11. So in this section, we get 6 and -72 over 11 as well. So I'm going to estimate where that is. And when this goes near our asymptotes, this is what's going to happen. Now our horizontal asymptote, the one that we have right here, that's what happens when your x values get very big or very small. I mean very big negative numbers or very big positive numbers. It is possible that your graph may go through that in the middle. So what we need to find out is what's happening in this graph. In fact, what's happening to our graph as it gets close to -5 and what's happening in this graph as it gets close to 5. We'll start with close to 5 because it's going to be easier for us I'm just going to take a picture of that. Did that work? Did that do anything? No. Try that again. Wow, that's big. Just so that we can see it over here. Here's our equation. We want to find out what's happening to this equation as we get close to +5. And what I mean by close to +5, that would be like 4.9. And 4.99 would be even closer. And 4.999 would get even closer. Okay? What happens when I plug in 4.999 into the top? I want you to see that on the top I'm going to get a negative number. It's going to be really close to -50. Because if it's really close to 5, and when you plug in 5 into the top, 5 squared is 25, and 25 times -2, it's going to be close to -50. But I'm just going to write a negative on the top for an idea. Okay? Because what we're going to find here is when we plug in a number close to 5, can you see that this one, the x minus 5, is going to get really close to 0? But if I plug in 4.9, will it get close to 0 from the positive side, or will it get close to 0 from the negative side? Negative side. So I'm going to put a negative there as well. Because that, if I put in 4.9, this would be, even though it's getting close to 0, it's going to be negative. Okay? And if I put in 4.9 here, this is going to be positive. Does that all make sense as far as positives and negatives for each of those sections go? Overall, if you have a negative number divided by a positive number times a negative number, is that going to be positive or negative? It's going to be positive. Now, the positive idea is the important part. The other idea is whenever you divide by something close to 0, okay, what that means is you're dividing by something very, very, very small. So if you had a cake and you sliced it up into very, 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 very small pieces, how many pieces would you get? A lot. And if you sliced it even smaller, you'd get a bigger a lot. And the smaller you make it, the more and more you would get. So the idea here is that this, because I'm dividing by something close to 0, is going to get very, very big. In fact, the closer I get to 0, the bigger it's going to get. And it's going to become a very big positive number. So how does that show up on my graph? That means that our graph, as it gets close to x equals 5, is going to go up to infinity like that. Now we're going to find out what happens when we get close to negative 5. So I'm going to erase each of these, have my factors there. Can you see that it doesn't matter positive or negative? The top is going to be negative if I tried negative 4.9. And if I tried negative 4.9 into this first one, do you see that this is going to get close to 0, but still going to be positive? And this one is going to be negative. So what I was wondering about is this graph going to come down towards this asymptote, or is it going to go back up towards the other asymptote? And in this case, it's going to, because this is still going to be positive, and it's going to go back up towards that asymptote. So that's how we can find out the behavior as it gets close to those asymptotes. Now, we made some assumptions on the outside, but you could check if those assumptions are correct. Let's look at this one here. I said it's going to go down to negative infinity when it got to that asymptote. We can check that by thinking, what happens when I put in a number close to 5 from the right? Can you see that would be like 5.1? If I plug in 5.1 on the top is still going to be negative. When I plug in 5.1 here, this is going to be positive. And when I plug in 5.1 here, this is going to be positive and close to 0. All of those put together, a negative divided by two positive numbers is going to be negative, and because you have really, really small pieces, it's going to go down and get to be a really, really big negative number. So we were right in those sections. So to recap, what did we do? We found our non-permissible values first and found out that they were both asymptotes, not wholes, because none of our factors canceled out. Then we decided to look, are we going to have horizontal or oblique asymptotes? And you look at the highest degree in the entire thing. In this case, it was an x squared. And we had negative 2x squared on top and 1x squared on the bottom. Since that simplifies to negative 2, that's telling you that there's going to be a horizontal asymptote at negative 2. We found our x-intercepts and our y-intercept, which happen to be the same thing. Happen to be at 0. We drew our asymptotes. We found some points in each of our sections. And then we thought about what's happening as we get close to those asymptotes to figure out if our graph goes up or down. And in this case, this is the graph that we got. All right, so questions for practice with example 2 is number 4.